Hello, Mr. Katz and Mr. Engoron's class. The point of this video is to teach you and give you some practice on how to reflect and translate full lines. Now, in class, you did this with points or with shapes, but lines are a little bit different. And there's actually, I want to say, an easier way to do it, but you might prefer what I think of the longer way, but there are two ways to do this. So, first of all, let's talk about translating. All right. So here's a line in front of you. This line has the equation of y equals negative 2x plus 2. The y-intercept is positive 2. It goes down 2 over 1. That's where the negative 2. And if you wanted to make it negative 2 over 1, that's fine. So we're going to go ahead and translate this to, let's say, up 5. Okay. So if you were going to translate this line up 5, you can watch a lot of videos on YouTube that will literally take the points and go up 5, up 5, up 5, and then write an equation of the new line. Mr. Engoron and I kind of agree that there is an easier way about manipulating the equation, because you'll get the same answer if I go up 5, 1, 2, 3, 4, 5, and put a point, and then take this one, go up 5, 1, 2, 3, 4, 5, and then write a new line. Getting the equation is kind of tedious. So what we'd like to do is you are allowed to take this equation and you are allowed to actually manipulate this equation so that you get a new equation automatically. So up 5. Now when you go up 5, what ends up happening is it kind of shifts everything over a little bit, and because of that, you actually do the opposite for y. It's kind of a hard concept to explain, but basically, even though you're going up 5, you put a y minus 5. It's always going to be the opposite of what you're doing. But notice that I'm putting it on the y because when you go up or down, it's affecting the y coordinate. So then what we're going to do is we are going to...
If you want this for the quiz today, some of my students asked for it, and I thought it was a good idea. It's basically some basic graph paper.
We're going to go ahead and solve the equation for y. So if I add 5 to both sides, you're going to get negative 2x, and 2 plus 5 gets you plus 7. Okay? Now, this equation ends up being the equation after a translation of up 5. And if you think about this, so if I go up to 7 and I go down 2 over 1, down 2 over 1, you're going to notice that I get those same points that I would have got, by just translating the actual points. But this ends up becoming, because you could go directly from equation to equation. So I know that this line, after a translation of up 5, you would get this new equation. Okay. So again, I like to just manipulate the equation. So if you were, just another example, if you were taking that same line and you were translating to the left 3, well, left 3 usually means minus 3. But when you manipulate the equation, you actually have to do y equals negative 2. I said left 3, so it's actually going to be x plus 3. Plus 2. Notice that I put the x plus 3 in parentheses because that's the new x. So in order to find the new equation, you would distribute, combine like terms, and you would automatically have your new equation, which would be 2x minus 4. Also, notice that when you translate or, when you translate or, negative 2x minus 4. When you translate, the two lines are actually still going to be parallel, which means they're going to have the same slope. You would have got the same answer again if you just if you take each point and just go left 3. So this point goes 1, 2, 3, 1, 2, 3, 1, 2, 3. And if you found the equation of this line, it would be y equals negative 2x minus 4. So same things works with reflections. So let me go ahead and erase this for a second. Now let's say I take this same line and I want to reflect over the x-axis. Well, if you want to reflect over the x-axis, remember the rule is the y becomes the opposite. Remember the coordinate notation of reflecting over the x-axis is xy becomes, I said over the x-axis, so if we're going over the x-axis, it's the y that becomes the opposite. So you can take each one of these points, and if you go to YouTube, more than likely you're going to find videos where people are just taking the points and reflecting the point. And by reflecting the point, meaning, so this is the point, well, let's use this one right here. This is the point -1, 4. If I reflect this over the x-axis, the point is going to become -1, -4. So they basically do that to two of the points, and you can find the equation of your new points. But Mr. Angoran and I kind of agree that you are allowed to manipulate the equation. If we're just looking for the new equation, when you are using this rule, basically the y is becoming the opposite, so we're just going to put a negative sign in front of the y, write everything else out. And then remember, to graph an equation, one of the easiest forms for an equation to be in is slope-intercept form. So we want this to say y equals. So I'm going to divide everything by -1, and that will leave me with y equals 2x minus 2. So if I go ahead and graph y equals 2x minus 2, I'm going to get this line after a reflection over the x-axis. If I wanted to come up with a couple of coordinates that would work, well, then that's just about plugging whatever x you want in and finding out the y. So when x is 2, if I put a 2 in there, 2 times 2 minus 2 would be 2. So that could be a coordinate of my new line. I'll put in a 0. When I plug in a 0, 2 times 0 is 0. 0 minus 2 is -2. So plotting 2, 2, and 0, -2, and connecting that line would show a reflection over the x-axis. Okay. And that's how you would basically do those things. Now let's get some practice. So if you turn to this in your workbook, I believe it's either 26, 27, 28. I don't have it in front of me, and I forgot to write down the page number. Before you do this, though, I'm going to ask you to do a specific question, and then I want you to pause it and do it, and then see if you got it right. Okay. So here's a line right here. This is the line y equals 1/2 x minus 1. Okay. Now, I do like to put a couple points in where I see it actually goes through the corners to know that these are actual points of my line. So the first thing I want you to do is actually not in your book. I want you to translate this up to and then find the new equation of the line. Pause the video, try it, and then play the video to see if you get it right. So for this one, translating up to meant that you should have made the y actually -2. So I would have done y minus 2 equals 1/2 x minus 1, and then I'm going to go ahead and move the -2 over by adding 2 on both sides, and that leaves me with y equals 1/2 x plus 1, and that would have been after a translation up to. And by the way, if you draw this up 1 over 2, you're going to see that not only is it parallel, but like every point went up 2. Now, can you go ahead and pause the video by doing this one right here? I want you to reflect this over the x-axis. So go ahead, and then hopefully you did that. Now let's see if you were right. To reflect this over the x-axis, it means the y becomes the opposite. So yes, you could have taken the points, but I'm just taking this equation and I'm putting a negative sign in for y. Then I'm going to solve this for y, and I get 1/2 x plus 1, which would have been your new equation after a reflection over the x-axis. Now go ahead, everyone, and try this one. Reflect it across the y-axis. Pause the video, and then play it when you're ready, when you're done. Right, so this one, if you reflect over the x-axis, it means that you would have made the x-coordinate negative. So you got 1/2 times -x, which is like -1x, minus 1. So for this one, I'm just going to have to simplify that. Negative times a positive would be a -1/2 x minus 1, and this would be your equation after a reflection over the y-axis. Last one, go ahead and try this one. Pause it when you're and then play it when you're ready. So when you reflect something across the line y equals x, it means that the x and the y coordinate switch. So now I have x equals 1/2 y minus 1. Remember we said before, you really want to solve this for y so you can graph your new line. So I'm going to move everything over. I'm going to add 1 on both sides. And then I'm going to multiply by 2 to cancel out the times 1/2. And when I multiply this by 2, you get 2x plus 2. Because remember, you really have to multiply both of them by 2. And y equals 2x plus 2 would be the result of this line being reflected across the line y equals x. And to graph it, I would go up 2, that's my y-intercept, up 2 over 1, or down 2 to the left 1, which would be a negative, negative. And then if I connect these with a line, which you should use a ruler, that would be after a reflection across the line y equals x, which, by the way, makes sense because the line y equals x is this line. And you could kind of tell that this is flipping over. The distance from here to here is the same as the distance from here to here. Right? And I hope that helps.